Ensoftec has developed a series of videos for the selection and design of stormwater facilities for land disturbance projects. In this video, I shall show you the design of micro-bioretention or rain gardens using SWMSOFTVA. Virginia Department of Conservation and Recreation, or DCR Specification Number 9 gives a complete description of these facilities, their performance and criteria for design, their feasibility and design applications, regional and special case design adaptations, their construction and maintenance. The pictures and tables shown here are from these specifications. Bioretention creates a good environment for runoff reduction, filtration, biological uptake, and microbial activity, and provides high pollutant removal. Bioretention can become an attractive landscaping feature with high amenity value and community acceptance. Small-scale or micro-bioretention used on an individual residential lot is commonly referred to as a rain garden. The major design goal for bioretention is to maximize runoff volume reduction and nutrient removal. To this end, designers may choose to go with the baseline design, Level 1, or choose an enhanced design, Level 2, that maximizes nutrient and runoff reduction. If soil conditions require an under-drain, bioretention areas can still qualify for the Level 2 design if they contain a stone storage layer beneath the invert of the under-drain. The required filter bed surface area, F, is computed using the Darcy's law. This will be approximately 3% to 6% of the contributing drainage area, depending on the imperviousness of the CDA and the desired bioretention design level. The bottom of the facility should be at least 2 feet above the seasonally high groundwater table. This may be reduced to 12 inches in coastal plain residential settings. The contributing drainage area for micro-bioretention or rain garden is limited to 0.5 acre. Let me open a project and go to the BMP design. I am going to use the example project that we created earlier. BMP3 of Outfall 3 is a micro-bioretention. I select BMP3. I go to File, Design BMP Facility. This opens the micro-bioretention design screen. You will notice that the contributing drainage area, the percent impervious area, and the treatment volume fields are already populated. Default values are entered for the coefficient of permeability, design filter bed drain time, and porosity of filter material. These can be changed by the user. I enter the bottom of filter bed. This is for bookkeeping only. You will notice that pre-treatment types are shown here. Pre-treatment for rain garden consists of leaf screens or a mulch layer to keep the heavy loading of organic debris from accumulating in the bioretention cell, grass filter strips adjacent to a rain garden, or gravel or stone diaphragm at the end of concentrated inflow points. After entering all the open fields, I click on the Design Micro-Bioretention button. The program calculates the required filter bed area and compares with the area provided. At least 75% of the water quality volume should be held prior to infiltration. The filter bed drain time for rain gardens is 2 days. The adequacy of the temporary storage is determined. The remarks will show if the design is satisfactory or not. I go to the top menu bar and click on File, Save. This will save all the data including the results. I now go to the top menu bar and click on File, Print. The print report, which is in Excel format, gives the results of analysis. Rain gardens are generally located as offline facilities. Low-flow diversions or flow splitters in the form of a weir or curb opening sized for the treatment volume help minimize clogging and reduce the maintenance frequency. The program lets us design flow splitters. For this, I go to File, Splitter Design. This opens the flow splitter bypass worksheet. You will notice that the water quality discharge and 10-year peak discharge are already populated in the form. I enter the bottom width of the concrete flume or the curb cut at the top and the length of bypass weir to convey the 10-year flow. When I click on Compute, the program calculates the hydraulic head required to divert the water quality discharge to the facility and the hydraulic head required to divert the 10-year flow away from the facility. I enter the heights provided and go to the top menu bar and click on File, Save. This will save all the data including results of analysis. I go to the top menu bar and click on File, Print. The print report, which is in Excel format, gives the results of analysis. This completes the design of micro-bioretention facilities.